This tutorial goes over the air handler baseline worksheet, which requires that an air handler was added as a piece of equipment already. See the equipment worksheet tutorial for more information on how to add equipment. Our building's air handler and this worksheet is titled AHU 403. On this worksheet, we'll define the baseline operating characteristics of this air handler. This worksheet is broken into sections, starting with the general information section at the top left, and it gets more specific as you progress down the worksheet. As you can see, the worksheet is also pre-populated with example inputs. Remember to use the help menu function, the question mark, in the upper right-hand corner if you have questions about any of the input fields. So this help menu brings you directly to the AHU component section, which represents this worksheet that we're on, and discusses in more detail all of the input boxes. Okay, let's close out of that. So first we choose the baseline equipment operating schedule. Let's say that the air handler runs Monday to Friday from 6 a.m. to 6 p.m. and is off Saturdays and Sundays. So we're going to select the schedule that we created, Monday to Friday, 6 a.m. to 6 p.m. This was created in the schedule tutorial. Most utility tariffs assume that weekends are off-peak, but this tool uses the day schedule on the utility tab for all days of the week. So if we had weekend operation, we would have to run the tool again using a weekend-only schedule and add the savings from that to the savings for the Monday through Friday schedule outside of this tool. Okay, moving down on the inputs, as you hover over this cell, you see that there's a tip explaining what the input is. Let's input our fan heat as 3 degrees, which was also the sample there. Return fan, yes, we have a return fan. And our total static pressure, which is the total system static pressure when the supply fan is at the design flow rate, is going to be 4 inches, which is also the default there. The system no reheat point is the outside air temperature above which no reheat is allowed. And as you can see, there's a tip here too. Let's put in 90 degrees there. And then the fraction of zones of terminal boxes with reheat capability, we'll leave that as 50% also. And this cell, or the next cell, needs to be filled out depending on the type of fan control you have for your supply fan. The DT here stands for delta T, not discharge temperature, which may be confusing with the next cell. So let's leave these as is for now and go on to the duct static pressure information section. So in this section, to the right of the general info section, we input information about the duct static pressure set point. The tool allows for baseline conditions to either, your control method to either be a fixed control or a reset control. And if you click on reset, the inputs change. So now you're required to fill in the minimum, maximum set point and also the flow ratios associated with those. So for our baseline, our example building, let's assume a fixed control at 1.25 inches. Okay, scrolling down to the supply fan information section. Our capacity is 32,000 CFM. And here's another option box. Basically, it allows you to input the maximum fan power at design conditions, either calculate it based on the horsepower, efficiencies, load factor, etc. Or you can set your operating kW, which might be based on what you measured on site. And as you can see, it changes, your input cells change based on what you choose there. Since in our particular case, we didn't measure the kW, operating kW, so we'll calculate it based on nameplate information. And our motor size is going to be 40 horsepower, motor load 95%, motor efficiency 95%, our load factor is going to be 75%. And here is where you choose your fan control. Your supply fan can either be constant volume or variable volume. And there's a few different options if you choose variable volume. So let's see what happens if we do that. As you can see, the cell you need to fill out changes up here. So now you have to fill out the reheat air discharge temperature instead of the reheat delta T for constant volume systems. Okay, so our fan, let's say, is variable volume, and your fan control type, this is also a drop down. You can choose discharge dampers, inlet guide vanes, or variable speed drive to vary your flow rate. So we have a variable speed drive, and now we have to enter the variable speed drive efficiency, which is going to be 90%. Okay, let's go back up to this section and fill out our reheat air discharge temperature. Which is going to be 90 degrees. Okay, and then our return fan information. This is, all of these input fields are similar to what we did on the supply fan, and the options are the same. So let's just go through those real quick. We have a 28,800 CFM fan on the return fan. We're going to calculate it. Also, 10 horsepower, 92% motor efficiency, 75% load factor, and we have variable volume with discharge dampers to control the flow rate. Okay, so general information, duct static pressure information, supply fan and return fan information are all filled out. So let's scroll down a little further here. Now we need to enter 4 points to describe the supply fan airflow over a range of outside air temperatures here. These regression points, which we're going to input, were developed in the regressions tutorial, which explains how to determine what points should be used. And let's see, we've got, from that we'll use the values 50 degrees, so 50 degrees outside air temperature, and our airflow at that temperature is going to be 62%. 55 degrees outside air temperature, our airflow is going to be 68%. 60 degrees, 74%. 65 degrees, 80%. Okay, and as I entered that, you could see over here the charts changed to show you your regression points. For outside air temperatures beyond the regression points, the CBOE tool will assume the performance of the last point. So temperatures below 50 degrees, it's going to assume that your airflow stays constant at 62%. And the same thing with outside air temperatures above what you input here. So above 65 degrees outside air temperature is going to assume a constant flow rate of 80%. Okay, the next section is for the supply air temperature regression. Some systems use a supply air temperature reset strategy, and this strategy can be modeled by this tool by using this input section. For our example building though, we'll assume that the supply air temperature is 55 degrees year-round. And I'm going to change our outside air temperatures here to match the minimum the range of temperatures that we would see for this particular climate zone. And in order to check and see what the temperature range is, you can go to the demand tab. Let me zoom in here, which shows you a highest and lowest temperature for each month. From here we can see that our lowest temperature is 35 degrees and our highest temperature is 95 degrees in September. So we're going to cover that whole range, and so we're going to start 35 degrees. I'm just inputting various numbers here between that outside air temperature range, and we're going to stay at a static 55 degrees supply air temperature. Okay, so similar to the supply air temperature regressions, a return air temperature regression can be input in the next box down. This is often developed using trend data across a range of outside air temperatures to see how the return air temperature is affected, if at all, by varying outside air temperature. For this building, let's assume there's a slight increase over the range of outside air temperatures. So again, we're going to change this range to what's seen year-round in our climate zone. And our return air temperatures, maybe 71, 72, 73, and 74 degrees. And again, with all of the regressions, you can see the chart on the right change as you input your values. Okay, the mixed air temperature section is a little more complicated. There's a couple options down here. You can either calculate the mixed air temperature based on a fixed outside air percent, or you can calculate it based on a fixed outside air flow rate, or based on an economizer minimum and maximum damper positions. So let's just click some of those and see what changes. So note this cell down here, the heading changed to fixed outside air flow rate, CFM. If you go to econo, it'll change, and now you're required to enter the minimum and maximum outside air fraction. And then go back up here, and you can either calculate or you can input directly, similar to your supply air temperature regression, your outside air temperatures and mixed air temperatures. So for our example building, let's assume a fixed outside air percentage. So we're going to go calculate fixed outside air percent, and we're going to assume that the outside air dampers are stuck at 45%. Okay, so now if we click the Calculate MAT button here, we'll see the regression values show up based on our previous inputs for the outside air temperature, return air temperature, and this damper percentage. Scrolling down, at the bottom here, you can enter a kW per ton regression, or your cooling plant efficiency regression, for the cooling system associated with this air handler. This section is helpful for buildings with a mix of packaged rooftop units and built-up systems supplying chilled water for air handler units. In order to allow this ability, you have to check this box here that says use instead of central plant, and then you would enter it similar to your similar to what there is on the AHU heating and cooling tab here. So this is what it would use if you do not check this box. So let's go ahead and uncheck that, because we don't have a packaged unit in this case. And then over to the right is a user documentation section. This is where you provide notes related to the inputs on this tab, or reference the document template tab as needed for background information. For example, if your building had additional air handler units, if your building had additional air handler units where you're proposing an energy savings measure, you might want to return to the equipment tab to add another piece of equipment. And if it was the exact same or quite similar to this air handler 403, you could copy this information through that tab.